React's been getting some crap for their decision to override various globals, specifically fetch, which they've walked back, but now they're also overriding date. I obviously lean towards those overrides being good for various reasons, but not everyone agrees, including Artem, who, if you're not familiar, is the creator of mock service workers and one of the more legendary people in the unit and like code-based testing side of the TypeScript world. Fantastic developer. I've had great conversations with him, highly respect him, but we don't agree. So I want to take the time to read this with y'all and see where we stand in the end. Without further ado, let's get started. Why patching globals is harmful. Honestly, I never thought I'd be writing about this, but the matter of patching globals turned out to be one of those topics that a lot of engineers seem to misunderstand. Most of us don't do monkey patching, and even fewer stay around those implementations long enough to witness their impact. All the more reasons to talk about it. Throughout the next few thousands of words, I will be referring to modifications of global APIs as patching. You take the code you don't own, you modify its behavior, you patch it. I hope we are clear on semantics. Yep, totally clear so far. I am using React, Next, and Bun as examples in this article because they've introduced features built on top of patch globals in the past months, which was met with a sizable backlash from the community. This piece is not part of the backlash. If you came here to bolster your dislike towards these projects or companies behind them, I kindly encourage you to close this tab and go on your way. This is awesome, by the way. I don't see anywhere near enough of this like anti-content that is like clearly drawing a line of this isn't meant to be used as ammunition to go after these people. I have this specific bone to pick. Why this should not be used in this way. Really cool to see this. This sets a really good tone as I start reading. So already more inclined to vibe with this. I voiced my concerns about the matter publicly and saw firsthand how deserved criticism is muddied with blind hatred, and I wish to contribute to that kind of discourse no longer. Yeah, absolutely agree. The deserved criticism is muddied with blind hatred. I feel this so hard, y'all have no idea. You have no idea. It's really annoying that like I feel like I can't critique certain things because it will be used to just muddy things further. I don't let it stop me. I still, if anything, I'm probably more negative towards the things that I talk about than I was before. Like since Vercel started sponsoring me, I've been way more critical about everything they're doing, which is funny that I get more shit now than I do before, but it is what it is. Thank you for calling this out. Really appreciate it. I love API design. All of the said companies have featured excellent design choices in the past. Today, you'll learn why patching globals is never such a choice, despite its reasoning and appeal, which we will also discuss. Interesting angle so far. Background. I first came upon the patching issue when I heard the announcement of the new caching API in Next. While the feature itself is a great addition to the developer and user experience, the proposed public API was rather unusual. The team had decided to provide a Next.js specific feature by extending a standard global API, fetch. Here is the example with the new fetch next override. They added the next key to fetch, which lets you do things like call or revalidate here. If this is going to be the focus of the fetch part, we might end up agreeing more than y'all might expect, but the fetch React override and the fetch next additions are slightly different, but we'll see where we go. After looking more into this, I've soon discovered that React itself was patching the global fetch function to cache server-side requests in their in-progress React server component model. This is one of the most used JS frameworks and one of the most used JS meta frameworks, introducing what I find to be a rather harmful design pattern. A few days ago, I stumbled upon a tweet from Bun reminding its users about a convenient way to proxy HTTP requests. All it takes is to give any fetch request a simple proxy option, as such here. I'll admit that different runtimes adding these things are even sketchier to me, because like if Bun the bundler would at bundle time introduce a proxy and a polyfill for it, that's one thing. But a runtime adding overrides like this is a lot scarier, even if just for like the type safety side. We're going to talk more about Bun and fetch though, don't worry, because there's a lot of weird things about the fetch standard that Bun has been dealing with. At this point, it was the third time a major framework, or in this case a runtime, introduced a feature that relied on modifying an existing global API. I did, and still do, assumed the good intention from the authors, yet I couldn't help but worry that it was an oversight, an accidental spark of a flint that, if not doused, would shroud our whole dear forest in fire. Interesting reach. I have thoughts, but I don't want to just stop and go on a tangent just yet, because I have a feeling he's going to address most of my thoughts. But why do I think these APIs are bad? What's so harmful about them? Answering these questions without understanding the reason behind those design decisions first would simply be improper. Yeah, this is a great article so far. I'm loving this. The appeal of patching globals. It's not an easy thing to come up with a good API, even more so with an API that would be used by thousands of people. I think thousands is a bit low here, but I get the point. Thousands of people is a pretty low number for React, but still I don't even want to think about the hundreds of thousands who consume these things. It has to be intuitive, concise, solve the problems it sets off to solve all while being efficient about it. There's a lot of boxes to check, with some of them pulling your judgment in opposite directions. Luckily, all three examples we have today happen to concern fetch. It's a global function to make HTTP requests on the web, and it's known and used by a lot of people out there. You call fetch when you want to make a request happen. Isn't that the perfect place to say you want the request to be cached as well? Maybe proxied elsewhere? And because it's a global, it doesn't even have to be imported. We are checking off these boxes so fast, we're grinding pencils to stumps here. Yeah, I will say for traditional request caching where like future requests are hitting a cache and proxying. Yeah, the one thing that's missing here, and I'm curious if this gets touched on as we go or not, is the idea of deduping within a server request such that the requests being made aren't being hit an unnecessary number of times. In the end, why should anyone go through the trouble of inventing custom functions and methods for something the platform should have had to begin with? And I do get this appeal, I truly do. There is, however, a cost to every decision, and patching globals doesn't just have a cost that affects both users and maintainers, but it also actively harms otherwise great APIs and even the language itself. Now to the specifics. Harm number 1, maintenance. When you patch a global, you modify something you do not own. Fair? Technically, this is the case with global this too, and like window, but fair point. Maintaining the things you do not own is hard. That is why you should always strive towards making the experiences you ship apparent and explicit, like so. Import experience from your thing. This will also help you assess the blast radius of any changes that you decide to make to your framework in the future. See, the globals are precisely that, global. The only thing worse than thinking you can predict all the possible ways a global is used in the wild by both your users and other tools is to assume you can accommodate for it. Context. Hi, I patch globals for a living. I don't enjoy that. I actually hate that. And I'd move away from that instantly if I had any other choice. And I did, moving the network interception to a service worker the moment that it clicked. Yeah, the fact that mock service workers is the thing you created as a way to get around overriding stuff, you're very uniquely qualified to be talking about this. And good qualifier here. Sadly, the nature of what I do doesn't give me much choice. Luckily, all the frameworks I bring up as examples today do have that choice, and I'll even show an alternative design to their APIs later in this article. I'm going to show you some edge cases that those alternative designs cannot handle, but we'll get there. You can take my word for it, or you can wait for your users to tell you how meddling with globals breaks their apps and what an excruciating pain they had to suffer to discover that. You've effectively thrown a bear trap into the source code, and someone's going to get caught. At least, it won't cost them hours of their lives and sanity to fix the issue, but it will cost you. Using a more concrete example, imagine your framework patches the global fetch functions to dedupe requests. Ooh, I might be getting owned here. This works really well for the immediate consumers of fetch, your users. Now what happens if they rely on a third-party SDK that also has a dedupe mechanism built in? The two behaviors would clash, causing all sorts of weird issues that are virtually impossible to debug. Interesting, because I was going to show cases where the third-party SDK doesn't have a dedupe built in, and if it's making multiple requests, that can get really annoying. So if I have like function, just get user info, user ID string. So this function. And one of the things this function does is check that you're authenticated first before doing the rest. So we have like const auth equals await, this has to be async, fetch /auth service. And we have to wait to make sure the user's off. And then we const user data equals await fetch user data, return user data. Like if we had 4 different things here where like this auth call was being made by an SDK like this, if this was being exported in a package and it was to do this dedupable thing that can be checked across 5 places, and you have to wait for this fetch to happen 5 times, there's nothing I can do now as a consumer of this API. If I could break in and cache this manually, cool. But if I wrap this, if we have a different function though, that's like get app info, and this gets app data. Again, remember, pretend we didn't write either of these. If these were being provided by an SDK, and we wanted to make this fetch call not happen twice. If I'm calling get user info and get app info, I'm now calling the auth service call twice. And if this is how the SDK we're using was implemented, which many are implemented not far from this, it doesn't matter if we wrap get app info or get user info in a cache, because that cache only affects that function. It doesn't affect the things inside in the potential to dedupe those. I'm ready to take the blame for proposals that took me a few seconds to come up with. Ideally, SDKs give you fetch as an option, and then you can imbue it with caching either on the framework side or your app side. Give people their fetch. If you want to enforce things like that, do once, as many other SDKs do. The fact that I now, as the consumer, have to think about that, and as the creator of the SDK have to do that too, is a bit annoying if the goal is to just provide a good experience for server-side React. The harsh reality is that a lot of these libraries are making bad assumptions about things being on the client, and this lets you skip a lot of that by overriding the fetch at this level. If by default, 2 identical fetch calls on a server-side request are deduped, that is a potential massive win. Is that win worth all of the potential breakage, all the potential additional issues? Up for debate. And that's why we're having this discussion right now. Anyways. This is your best case scenario. The worst case scenario is that the third party was also patching fetch and relying on that patch to exist, which your framework successfully undoes by introducing its own patch. A magnificent manifestation of hack-driven development at its finest. I think the slippery slope argument's actually one of the stronger ones here, where like if React patches fetch, can't everyone patch fetch? And now you're in a terrible like overriding hell. It's like cascading, but worse. It's like we're taking the worst part of CSS and applying it to JS. So I'm going to think about this now. Harm number 2, predictability. There's hardly anything more satisfying in engineering than knowing how a thing behaves. If you use a console log, you know it will print a message to the console. Now, it may be the browser's dev tool. I have to riff on this a bit because you don't know this anymore. I will say as a diehard Next.js and server component developer, console.log doesn't always go where you expect it to go anymore. Like if you don't know if something's running on the server or not, or if it's running on the client or not, or if it's cached or not, that console log might just not happen. But yeah, for the most part, I agree. I fully agree with this. It's just funny that console log isn't even sacred ground anymore. Now, it may be the browser's DevTools protocol that does it, or Node's writing of process to standard out, but you do know what's going to happen. You know what's supposed to happen. But yeah, you can predict that behavior. There's hardly anything more irritating in engineering than having the same thing behave differently. Whew. Yeah. I don't think there's a point in here so far that I agree with harder than this. Oh, God. Yeah, I remember a long back and forth I had with Dan Abramov around use effects, like different behavior in dev mode. Yeah, fully agree. You've been building for web long enough. I'm sure you have your own barrage of oddities, quirks, and behaviors of questionable sanity corked into memories you never wish to revisit. It's my job to revisit them, sadly. Remember how display flex used to only work in some browsers? Oof, that hurts. That hurts my soul. What about negative look behind in Safari? What about regex look back in Firefox? Or just anything I've already seen in Firefox? For all those joyful hours spent begging IE to render your page correctly, if at all. I had to push so hard to get Twitch to drop IE. God, that's the chaos that happens when multiple agents implement the same thing differently. Yeah, it's a shame that fetch only got added to Node like a year ago. It makes me appreciate the present even more. Cross-browser compatibility has never been higher. Even cross-environment compatibility is showing incredible progress, with Node shipping the fetch, readable stream, WebSocket, and a dozen other browser APIs. It didn't happen by accident. We, as an industry, came to the conclusion that nobody wants to waste money and time on compatibility issues. We invested into specifications, we deprecated old, and gave way to the new. I have to call out the fetch thing and the idea of standards quick. This is a fun example of how these standards are all made up things. What do you expect the content length received by the server to be? So you set body to 1, but you set the header's content length to 2. So it's still going to be length 1 or length 2. Currently, Chrome, Safari, and Bun do the same thing here. The content length would be 1. But Node, which is using Undisi as its fetch layer, throws. The reason I bring this up is the debates that it's causing because of those differences in behavior. If we hop to the quote tweets here, Luca from the Deno team dropped his spicy take. Crowdsourcing implementation behaviors because you're too lazy to read the spec? The correct answer is 1. Here are 3 links describing the answer being 1. But Bun's creator Jared replied, we did read the spec, and that's why Bun behaves like Chrome and Safari here. It's also helpful to see what other developers expect. The other important part here is that, as Jared said many a time, if it works in Node and not in Bun, it's a bug in Bun. And I think that's important to understand, is that Jared's goal here isn't just to follow the standards perfectly, it's to make sure that our expectations as developers are met. And if our expectation is that Node works this way, so when we run the code in Bun, it should work the same way, that's a fair thing. And effectively what he's asking here is, should we do things the way the web standards expect, or should we do things the way Node expects? Which is a great question to ask. And it's really frustrating that the response to this from a competing team, which by the way, like Luke is not on Node, he's on Bun. I really hate the infighting going on there because we all have the same goal of pushing the Node ecosystem forward with alternative approaches. The dunking here was just really sad to see, but that's what happens when we end up in these contentious places around standards, because none of these standards are actually followed properly across all places. Pretending they are is absurd. So while I agree we should be putting our best efforts into following these standards, I think our expectations as developers don't always align with those standards. As a result, things are chaos. Did I say he's on Bun? He's on Deno. My bad. Luke is on Deno. Jared runs Bun. I don't like that Deno and Bun beef It's annoying. Hate to bring that up here, but I do think it's relevant because the point I'm trying to make is that these globals being patched are also not as standard as we like to think. And like fetch in Node is still very new, very early, has all sorts of quirks. We had some fun bugs when we were working on upload thing where the way fetch worked for like files for posting from 1813 to 1817, the behavior was different. And then 1817 up, it just worked how we expected. But like, it's not that simple. This has been a chaotic ride for a lot of us. And now we've come full circle. We're back at the stage where multiple agents are implementing the same thing differently. Here's a request that will be cached and then revalidated after 10 seconds in next. Cache is force cache, next revalidate 10. This is new syntax being added to fetch that doesn't exist normally, that exists within the next way of doing things. Will this request behave the same in Svelte or in Remix or in plain JavaScript? Not really. The revalidating part happens to be a next-specific API leaking through the global fetch. It's a custom API disguised as a global, which drives its predictability to the ground. I will say for next doing this, largely agree. This probably isn't the right way to do things, especially with the lack of developer tooling and communication around Next's caching behaviors between requests. I'm going to pull back up Excalibur because I don't think I did a good enough job explaining this in my previous video, and I want to be really, really clear. There are two types of requests, or we'll call them page request and server-side request. The page request is the one that happens when the user goes to the page. So when I load a web page, the server has one request. Every time I press the refresh button, one page request happens. Within that page request, there are usually going to be a bunch of server-side requests. So we have our page request. The user requests the page. They're waiting for an HTML response. Within here, a bunch of additional requests are going to have to be made. So let's make a little blue box that's auth request. So we might have one auth request. We'll use the example above with the get user info. Make this one yellow, get user info. So within the get user info request, you might have to do an auth request. Maybe you use this request in like 3 places. I'll make this bigger accordingly. And we have a fourth one that is get app info. I'll make this one different colors. So we have our page request, and it makes all of these requests on it. Maybe we have a component that renders your user info. Maybe we have another component that is like your friends list that requires your user info. Maybe we have a third component that's like the top nav that needs it to know if you're logged in or not. These requests might be coming from an SDK. They might not be. These being deduped within a given page request, I think, is a good thing. The slashes mean this thing is hitting a cache and is not being re-requested. The solid colors mean it is already requested. So if we're on one page request, so the user requested the page, that page calls the auth request function 4 times, which is a fetch call, and it calls get user info 3 times, and it calls get app info once. The cool thing about the overriding of fetch is that the auth request call, as long as it's the same shape, only has to be made once across all of these other requests. Get user info also only has to be called once because it's being reused in these other places. Get app info still has to be called because it can't use the get user info cache, but at least it can use the cached auth request. Where things get sketchy is when this happens outside of page request 1. The issue that I think Next is causing is that these will get cached too. And now, on the next request, all of these things hit a cache in Next. I don't think it's fair to call what's happening here caching. This, to me, is deduping. And the term cache being used to describe this behavior is what I think is causing a lot of the issues people are having understanding what's going on. Because this isn't a cache in the traditional sense. It means that the fetch call is stopping to check something before it goes and makes the fetch request to see if it has the data it needs already or not. But within a page request, I think deduping is not a bad thing. Between page requests, deduping is caching. That's a lot messier. That is significantly messier. And I honestly think if this was all that was shipped and the rest was done through explicit cache wrappers, that would be much, much fairer. But this is like through one pass of a React render. This is one function call that happens to do all of these things within it. It feels weird to not be willing to dedupe there. Versus here, when you have a further request, having things cached for that next request, that's full of a lot of unexpected behaviors, a lot of bugs, a lot of things. I think I made my point here. Caching within a page request, cool with that. Deduping, awesome. Caching like this between page requests, without really good dev tools, incredibly unintuitive. Incredibly unintuitive. The other thing here that's important is that I don't think this should work on post requests because post requests are by design meant to represent destructive behavior, whereas this is supposed to be deduping fetch behavior. If you're doing destructive things on a get call, like incrementing a count or updating a user's profile, don't do that. Get is supposed to be for non-destructive actions. The same way you shouldn't have your service cripple if you get more gets than expected. Having your service not crumble if you get less gets should also work. The reason that they chose to also have this behavior work in post is obnoxious. It's GraphQL, because all requests in GraphQL are done via post, which is incredibly dumb. Y'all get the point. There's a lot of edges here. Blame GraphQL for this. Regardless, if this is how it worked, it was only here and it was just get, I don't think we'd have all of this controversy. Although I would assume that the author of this blog post would probably still be iffy on it. My gut feel is that he would be less so. Oh, there he is in chat. You can use get, but nobody does that. Yeah. The validating part happens to be a next-specific API leaking through the global fetch. It's a custom API disguised as a global, which drives its predictability to the ground. Yeah, I agree. Specifically, once you're doing this stuff where you're adding additional keys to the global, that's where things get iffy for me. And I totally agree. This, not great. But again, the example I was showing previously, you don't need to override anything for this to behave this way. There doesn't need to be any additional keys or anything additional in fetch. I would argue this is actually the way you would expect it to work in a lot of cases. I'm intentionally not giving examples of the standard behaviors of fetch working differently across runtimes. Those exist too, but there is also an effort to bridge the gaps and improve specification compliance. Patching, on the other hand, pulls the ropes in the opposite direction entirely. This is like the opposite of a pre-watch, where I make a point and then I get owned for it a little bit later, which is the thing I went on the rant about with the bun stuff earlier and how node standard kind of sucks and doesn't follow spec. This is a very fair point. The fact that it doesn't follow spec, as much as I can use it as proof that these things aren't real, the fact that it doesn't follow spec is a problem that they're working to solve. And it's a fair point that when I see the spec not being followed, I use that as an excuse to not follow spec. When others see the spec not being followed, there's an opportunity to continue to bridge the gaps and improve. That is a very fair point. Yeah, I'll take the L. Harm number 3, learning. Ooh boy. A software that disregards the learning experience it creates is a tool destined to fail. I like where this one's going. Ooh boy. As a library author, I know firsthand how impactful the decisions I make can be for my users. There's already a lot of things that a good API must accomplish. It must achieve the task at hand, provide an intuitive, versatile means to do so, align with the established philosophy and best practices, be extendable and maintainable and transferable. But there's one more thing, the most important thing it must do. An API must educate. A good tool teaches you the concept, a bad tool teaches you itself. Whew. You drop in hard stuff here. I have a lot of thoughts on this. In fact, I'll do something you don't expect. I'm going to shit on Next real hard for a second. I've hinted at this here and there, but the more I've thought about it, the more I've realized how unacceptable it was to ship the state of server components without really good developer tools. The fact that we just recently got actual feedback in our CLI about what is and isn't being cached, that's absurd that it took as long as it took to get there. For a large portion of modern web dev's history, we've had a great way to debug things. Command Option I. We get this phenomenal set of developer tools that gives us so much insight on what's happening, why. We have all these different tabs for stepping through our code, for looking at what's happening network side, seeing what isn't cached, actually running JavaScript in the browser, depending on different things. And of course, we have the React dev tools with the components and the profiler. And somebody made a third-party React server component dev tool that I haven't had a chance to play with. My frustration is simple. We don't have browser developer tools on the server. For React to move to the server and force us to learn more important new things, it's a bit absurd that the quality of our developer tools had to go down so far, because this thing is going to be harder than ever to learn for most modern React developers, because a lot of them just haven't worked on servers much. And when these behaviors are now confusing enough that you don't immediately know what's going on, not having dev tools that make it really easy to identify those behaviors when they're happening is unacceptable. And I personally, obviously, we could not have known this at the time. A lot has been learned since, but I would hope that for future releases and developers working on things like this going forward, they will recognize that the lack of good developer tooling, developer tools is too wide a term. The lack of good tools for inspecting and debugging developer in JavaScript runtime stuff. We're so used to the quality of the tools in the browser that when you're doing things on the server, you have to bridge that gap yourself. And I haven't seen enough of that gap being bridged. There's too much excitement around these new APIs and not enough effort going into the tools we use to learn, debug, and better understand them. That's tough. And I hope that going forward, we'll see more effort into those things. It should be a much higher priority than it currently is. And I also think a lot of the controversy here would have been much, much smaller if we had developer tools to show us immediately and obviously what is and isn't being cached. That would have made this whole thing way easier to work with, and also would have made removing the global overrides a more acceptable path, because we could see and visualize clearly what is and isn't happening. Even just console logging to figure out what's going on here is more annoying than it should be. Anyways. Every time a user reaches for your tool, they have a problem to solve, and the solution you provide them is always twofold, the immediate one and the lasting one. Let's see where we're going with this. For lack of a better example, I'll shamelessly use one from my own experience. I spent the last year making mock service worker more spec compliant. The goal was to facilitate the standard fetch API, so the developer would interface with it more often. It was a challenge and a limitation I imposed on myself, knowing that the gains would be tremendous. So if you're not familiar with mock service worker, the goal is to let you mock specific browser things via a service worker so you can have really performant, like behind the scenes behaviors, especially for tests, in order to fake things like fetch. So when you're calling it in tests, you can have mocked responses that happen asynchronously so it behaves roughly how you would expect the browser to. Really cool stuff. If you think I should do a whole video on it, let me know. C, when developers come to mock service workers, they want to intercept requests and mock the responses. They could do all of that before, but the API was entirely contrived and specific to our library. So they have rest.get/user request response context return response context.json name John. This does achieve the goal. This does intercept the request and mock its response. It has that immediate solution right here, ready to be used. But boy, did it have no lasting impact whatsoever because it fundamentally failed to educate. Does the API teach you how requests are handled on the web? Does it let you explore what responses are and how to construct them? No, not really. Does it utilize the knowledge you already have to make your experience better? Nope. Ooh boy, spicy take number however many we're into at this point. Does this mean you're pro JSX? Because I would argue this is the beauty of JSX, is that every other framework at the time was inventing its own weird DSL on top of JavaScript, where JSX was like, we already know how HTML works. Why don't we just lean into that for UI structuring? I'm going to use this as a pro JSX take going forward. Does this make you a better engineer? Interesting thing to bold. Let's see where we're going with this. Let's return to our muttons. What does this example teach me about caching? Okay, I see where you're going. Fair point. This rots your brain more than it helps anything. Well, the first thing it teaches is that requests can be cached and that there's a standard cache for property that controls how browser caches handle these requests. So far, so good. But that's the standard teaching me, not Next.js. Fair. The next revalidate part is entirely contrived. Even if I looked it up in the next docs, I wouldn't know exactly what it's abstracting over. Does it control cache revalidation or does it do something else entirely? Certainly doesn't teach me about the max age request directive of the standard cache control HTTP header. Most importantly, can I write the same logic using plain fetch? Not really. Kind of, but I see the point. I genuinely didn't know. That's why I reached out to Lee for help. By the way, Lee proofed over this and has been a bro so far. I think he largely agrees with these things, so cool to have him involved the way he has. Generally, I've had good luck even before I was relevant, hitting up the Vercel team saying, hey, I have this spicy thing I'm going to publish. Can I get your thoughts? And I had multiple people back, super underappreciated blog, both by me and by y'all. I made a great blog post back in 2021 about Next.js and type safety being a total disaster. This has changed since, but there was basically no understanding of TypeScript at Vercel for a while, and it was incredibly frustrating. So I wrote this article about how bad it was. Before I published it, I sent it to Vercel. They left a bunch of comments. I looked through the things they recommended and ended up finding that they were even more broken than I thought. Next, I read an inference helper when using get server-side props called infer get server-side props, which had one of the worst type definitions I've ever seen. The inferable type it gets, it overrides as key string : any. So it's actual nonsense. And if you don't specify input types the way that it expects, it just infers everything to props never. It was awful. And I wrote this blog post because I thought it was awful. They recommended this as a thing to look into, and it ended up being more awful. But this resulted in a feedback loop that made Next better. Though I love that. And as much as we love to shit on Vercel, they are really good about responding to these types of things. There's probably no other company that's more willing to have a conversation with you if you have pushback on this stuff. Got a message from the author. Lee's gone over the top helping me with this. I expected to check the code snippets where I used Next, and he went on to giving me 30 plus comments on the entire thing, from the style to sentence structure to Next insights. Yeah. The way Vercel handles feedback is exemplary. Yeah, awesome that we're fully aligned. As we sit here shitting on Next.js design decisions, we all think Vercel handles these types of things surprisingly well. So once again, what Lee had to say here, he kindly explained to me that Next's revalidate focus is on incremental static regeneration, not just caching. So no, I cannot translate it to a plain fetch call. Seeing how tightly it integrates with Next, I believe it belongs to request init even less. Fair points. The ISR stuff is really cool, and even I struggle to fully grasp and communicate the relationship between the new Next caching stuff and ISR. We'll get there someday, but I really want to have better dev tools before I go all in on that. As powerful as the revalidate function in Next is, I wish it taught me more about what exactly it does, so I'd get a better understanding at caching and ISR, ideally while also relying on the existing standards that I can apply outside of Next. Yeah, and again, better developer tools to show you what's actually happening here. Ooh, that would help so much. Harm number 4, lock-in. I don't know how much I'm going to agree with this one, but we'll see where we go with it. The more sugar your framework sprinkles on top of standard APIs, the harder it is to move away from that framework. I would hate to be an engineer who has to migrate this from bun, in this case, the fetch proxy call, because I have no idea what bun is actually doing. I know what it's supposed to do from the docs, but the reality is often such that there are dozens of things that are happening under the hood. There's no spec for how proxy behaves. Now I have to match all of its behaviors while migrating, because each oddity missed is a new bug in my app waiting to happen. You took a thing you didn't own, you modified it on the premise of convenience, and now it doesn't work anywhere else because it was built in your own little universe. If that's not the definition of vendor lock-in, I don't know what is. Yes and no. I think the other problem here is that if you're wrapping these things with your own custom implementations, gutting that is even harder. Like if we go back to my Excalidraw example, if we had a React or Next cache wrapper that this library, get user info, applied to all of its auth fetch calls such that it could cache that layer, now this library is specific to our framework. The cool thing about the fetch override is that it allows for these behaviors to use a standard and then be embedded in something like React and Next and have all of these new behaviors and wins without having to integrate it into said SDK. So I think it's a two-sided thing here. I think on one side, it makes things less portable because you grow to expect these behaviors, but on the other side, it makes things more standard because you don't have to implement framework-specific stuff in your SDKs. So that's the catch-22, I would say here for that point. Largely agree, but I think there are benefits in terms of making things not locked in that happen here too. Author dropped another important point here that you could simply miss the proxy thing. Like you can leave it in there, expect it to work, and it just doesn't and not notice because you still get a response. Absolutely. Same deal with caching. It gets a little bit messy here because it's hard to know when these behaviors are or aren't working as expected, which is why I'm going to keep tripling down on the idea that like the missing piece by far here is the lack of good developer tooling. Let's take a look at harm number 5, hurting the progress. What appears like a pioneering of innovation ends up being one big spike in the wheel of progress. And it's a really, really big spike. Here's a quick history lesson for you. In the hairy days of the internet, there was a library called MooTools. Oh boy, it's going to be Squooshgate. It was a utility library to help developers survive the unfathomable chaos, which was web dev some 20 years ago. Its goals were noble. Its means, well, not so much. To be fair, we didn't know that its means were not good yet. We learned. We learned a lot. See? MooTools worked by imbuing the prototypes of global JavaScript objects with extra functionality. In return, you got a ton of useful methods, like array prototype get last, function prototype attempt, and number prototype limit. None of those really existed in JavaScript, but in the end, it was in such a sorry state to begin with. Nobody really cared. Yeah, like JavaScript was so rough that something coming in and adding all this stuff, not a big deal. Actually, big deal the other way. It was really nice. Until more and more sites got built with MooTools. And when the time came to define the next chapter for ECMAScript, to address all of those pains and make the language better, the committee was faced with a conundrum. They wanted to introduce new prototype methods on primitives, but they couldn't because half the web relied on the same methods from MooTools. Half the web might be a little much, but it was a significant portion. So if they wanted to add something that was already in MooTools, they would now collide. And if the browser version was different than the MooTools version, your app would break. Great times. Shipping these methods as part of the language meant breaking half the internet, which the committee found the wisdom to not do. Very fair. They had to bend the spec to reality. So we got string prototype includes instead of string prototype contains to stay consistent with array. Let me make this abundantly clear. The language itself couldn't become more convenient because developers were addicted to a convenience library that modified things it didn't own. Yeah, I'll see how that one settles. My immediate feels iffy on this, but my mind might change as we go. MooTools also spawned the smoosh controversy, causing a newly added array prototype flatten to break the web and forcing the TC39 folks to rename a perfectly valid method named toFlat. Yep, if you guys aren't familiar with Smooshgate, TLDR for this controversy is that MooTools had a flatten function on array. Theirs behaved in a specific way. When the browser wanted to add its own, it behaved differently. Forgot the specific difference is the MooTools one creates an enumerable flatten property, so it's later copied to elements. But if the browser ships a native version, it becomes non-enumerable and it isn't copied. Yeah, there you go. Theirs is enumerable. The browser one wasn't. It was going to be a mess because of the elements thing they had. Ugh. Yeah. So if your browser was expecting to run flatten and then get an elements object back, but it was instead getting array back because the browser overrode it again, it breaks. And the term smooshgate happened because somebody somewhat ironically suggested that we should just rename it to smoosh to avoid the compatibility issues. And that went viral. So everybody called it smooshgate as a result. Fun, beautiful mess, the usual things you expect from modern web standards. Well, web standards at the time. We've learned our lesson since, but that's Smooshgate. MooTools has passed into history, but its impact on JS has remained. So next time that you're choosing to support a short-sighted convenience, please do not complain if the web standards communities introduce a proxy target or proxy options property to the fetch API instead of a single proxy. Fair point. If now with bun standard, they can't use proxy for things in fetch, Fair. I admit, I don't know the details on why MooTools chose prototype patching as their design direction. I'll give them the benefit of the doubt, assuming that they thought it was the best way for their features to feel like extensions of the web in the language instead of a vendor library. Perhaps they simply didn't know better and there was no other examples to learn from. I am thankful they've become one for the rest of us. A truly fascinating part here is that none of these costs and harms would even be relevant if one approached convenience with a bit more thought and precaution. It's only proper that we looked at alternatives to patching globals. Sorry you had to write this. There are good reasons. We all have opinions. Anyways. Alternatives. There's a widespread misbelief that convenience either comes directly from the spec or it comes at the cost of violating one. I don't know how widespread this belief is. I do kind of have that belief. Like, I can be convinced either way. Again, JSX is an interesting example here, where JSX isn't JavaScript. It's not following the spec. It is hilariously more convenient. And a lot of the convenience is because it looks like an existing spec, HTML. Being against patching globals doesn't mean being against convenience. Fair. I would never, ever, ever say the author is against convenience. It's very clear here that he is more concerned about the longevity and potential ecosystem harm of overriding globals. Very fair. If anybody here thinks that he's against convenience, I'm on his side, not yours. He cares a lot about these things. Mock service workers is proof of it. You can still have reservations about these implementation details. I am all hands for convenience, and yet I hate whenever frameworks patch globals. There's one thing I hate even more: complaining without proposing solutions. Whew, you're dropping all of these bars in here. I love it. There's a ton of solutions to any API problem better than patching globals, and the quintessential part of any of them is being explicit. Abandon the magical, cast aside the pretense that you own fetch, and it is only through modifying it that you can achieve the golden DX you dream about. The DX is fundamentally and irreversibly flawed, and I've just given you 5 extremely detailed reasons above as to why. Fair. Let's take a look at Bun's proxy API as an example and make it more explicit. Await proxied request equals proxy URL, new request, and we fetch the proxied request instead. For this to work, my assumption would be that fetch would have to handle a proxied request differently from a normal one, that whatever this generates is not the standard object shape for what fetch expects. Like if I imported this from Bun, I created this, and I passed this to node fetch instead, or something else that isn't Bun's fetch. My assumption is that this wouldn't work. This has expectations, and that fetch has some implementation details that allow for this proxied request to go through fetch normally. But my understanding would be that this would have to be a custom fetch as well. Okay, so the request itself, so this request gets shaped so it's a normal request, but it happens to be hitting something else that has the right data to do the proxying. Okay, that's more fair. UNDC can do proxies according to chat too, through fetch ops dispatcher, which is already configured. Good to know. My curiosity here is that, like, are we more concerned about the API where having the proxy key here is the problem? Or are we more concerned about fetch itself having different behaviors that are overridden? My gut when I saw this is that this proxy call would have to be handled differently by fetch. So we're still patching fetch some amount. Response from the author: you're probably right. I hope it'd be possible for the request constructor level to handle this, but there's a lot of intricacies to handle. Yeah. I wonder if you could pass a promise to fetch as an argument. Hopefully no. Yeah. These are the concerns that I would have. Fetch with proxy. If no proxy, return fetch. Oh boy, an implementation for bot. Good stuff. Let proxy strings, proxy username, password, host, yada yada. New proxy agent, which is coming from UNDC, which, by the way, if you're not familiar, UNDC is how fetch works inside of Node. Proxy agent, URI, dispatcher agent. Is dispatcher part of the actual fetch standard? Cool. Yeah. So, yep. The proxying is mostly changing the request URL and proxying headers. Okay, it's in DC specific. Great. The reason I'm diving so deep in this, and I know it seems pedantic, there are 2 parts of this that are important to understand. I think I have to go back to Excalidraw for a minute, because we have 2 things here. When we're overriding the globals, we have behavior overrides and we have API overrides. It's rare you'll have an API override that doesn't also include a behavior override, but for the sake of explaining this, I'm going to separate the 2. A simple example of an API override would be something like the fetch proxy example from Bun, where this is a new API being introduced. It enables a new behavior, but this is a new API that exists in fetch, in Bun, and nowhere else. A behavior override would be something more like deduping requests in RSC. These things are very different. The API overrides imply a behavioral override or a behavioral change, but the behavioral overrides, as long as they're behaving in ways that make sense to the box they're contained within, I think this is fair. And I think that's the line I'll draw, is that API overrides for globals, messy, should be avoided. They do a really bad job with education. They do a really bad job with debugging. They make things worse for most people. But behavioral overrides within a given framework where they have decided in this context they want this behavior to work in this slightly different way. I think this is a fairer thing. And in the example here, I actually like this a lot because they have removed the API override by making it a thing you import. And my gut feel is that the behavior here would have to be different some amount when you pass this new object, but you're using the API the way it was designed. I think this is a really good balance, and it seems like author agrees. Explicit, predictable, love it. Not to mention that with the resource available for sell and button, folks could have designed a caching layer as a service worker for servers. Yeah. You cannot safely dedupe fetch without an API override. Otherwise, you'll dedupe calls that weren't meant to be deduped, like something non-idempotent. If you're fetching the same thing multiple times within one server request, they are idempotent. The user makes their request to the service, and then out comes the HTML page with all the content, index.html. So if this behavior was happening such that within multiple requests, you had deduping that you didn't intend, and that was causing requests that are idempotent and have specific expectations to fail, cool, totally fair. Don't think that should be the default. However, if a user is calling this web page, it would be unintuitive to call these functions in multiple places and have auth get called 4 times. I think this is the more intuitive behavior for GET requests. And if you actually have a reason that this request should respond to something different than this one, that should be included in the data that you're putting in the fetch call in the first place. But like when you're fetching on a server within a given request for a page, remember, once this is done, the user has HTML, and the cache in React no longer applies. Future fetches get new data. As such, I don't think this being built into fetch in React is a particularly big idea because it has allowed for a more intuitive behavior to occur that makes sense within the framework without really breaking things in other spaces. If this only worked via API overrides where I had to pass custom things to the fetch calls, that would be one thing. But this within the context of like this whole thing happens within like 100 ms or less. If you're expecting one request to be fetched 4 times and have a different response in these 4 places, even though all of the inputs are the same and the URL is the same, you have a really fucking shitty service. Like that is not a real expectation. That's absurdity. This debouncing makes a lot of sense, and it's confusing to me that people would push back on that. We're going to change this. We're going to have a page now that the fetch call is going to be get epoch time. So we're going to be literally fetching /time, and it's going to respond with epoch time, which is going to be a number that's different. If I call get epoch time 3 different places in my app, when I'm rendering this page, remember the output here is static HTML. So if I am requesting a page and I get this epoch call time 3 times, we'll put this in here. So say the epoch time was 12. Would you expect when you render this page for the 3 places you called this to be 12 all the same in the HTML, or would you expect it to be 12, 13, 14? It makes no fucking sense. It makes no sense that within one request, within one user request, that you would have different responses generating different HTML within the context of this one thing. If you're fetching the same thing, it's like you as the developer, you don't know which of these is being called in what order anyways. It's just so hard for me to fathom any scenario where you would want the same fetch call during the same user request to respond with different things when you're using get. Here's a common one. We have the like last updated at, or like time page was generated. If you have different results in different places on the same HTML, it doesn't make sense. Ryan Carniato is one of the best people when it comes to everything standards and web and JavaScript behaviors. I like his take on this too. It's worth considering. I don't like patching globals, but hydration is really nasty in general. Hydration is when you render something somewhere that isn't the browser, and then the browser connects all the parts again, so JavaScript can behave how you expect. Hydration is nasty, yes, and almost every framework has to do it in order to generate HTML on the server and then let the client take over. So because hydration is nasty and hydration is largely necessary with modern solutions, we're stuck in hackland. The whole thing feels like a hack. Without knowing the details, if one were to patch globals purely for hydration and nothing else, I think a hack to patch a hack is probably a very reasonable thing to do. Yes. Again, if it's not changing the API, it's just changing the behaviors in these specific, unique, admittedly hacky scenarios, much fairer overall. I went on that tangent for too long. Let's go back to the proposed solution, because I actually liked this proposal and I would be cool with this because, again, overriding behaviors for the thing within the context of your runtime, your framework, your stuff is different from overriding APIs. So the code in your thing is fundamentally different from the code in other solutions and doesn't follow the standards and specs. Is it actually an override if we talk about the new features in new runtimes? With proxy specifically, W3C spec says it's implementation defined, and therefore each fetch implementation just invents its own way to do proxies. Also a fair point. Like, we don't have a standard for this, and the expectation is that we define it ourselves. I think that should probably be defined outside of fetch or around fetch, but yeah, the lack of a standard existing is frustrating. With this change, the proxying functionality no longer appears from thin air. It has been imported from Bun explicitly. Nobody will confuse it with a standard JS behavior. In fact, devs will be reminded on every import that it is Bun who's making proxying easier. Use your developer-oriented marketing as a side effect of being a good API design. I don't love having to import always, but fair, very fair point. I like the explicit nature here. I generally lean towards explicit where possible, as long as it doesn't hurt my ability to interface with other SDKs. We can no longer shove it into fetch, so we have to be smarter about our proxy function. We want to proxy a request, right? So maybe let's accept any request instance as an argument and return a proxied request. It doesn't interfere with how a request is constructed or a fetch call is made, all the while it's achieving the same proxying functionality. Yeah. I love that. As a result of being an explicit utility, our proxy function doesn't suffer any of the drawbacks inherent to patching globals. It's a function owned by the framework, which makes it easy to version, maintain, modify, and deprecate. It's predictable because you clearly see where it's coming from and what it does. Most importantly, it doesn't masquerade as a native JS behavior. I like that you're calling this out, that it's not pretending to be native JS specifically, and that you say this is most important, because I agree. And this is actually really helping me understand where a lot of the issues are coming from. It seems like the API changes are significantly more frustrating to people than the issues that we have with the behavior changes. I think behaviors being a thing that exists within a solution is very different from API changes to globals. And I like that this is being separated so well here. It's extremely easy to learn as well. You go to the Bun documentation, see the function call signature, and wait, what's request? What? I have to learn how to construct requests on the web now? Damn you, Bun. I didn't ask you to make me smarter. There's no lock-in by design. And if you wish to play chaotic good here, you could even publish proxy for other runtimes to use. This is what I was saying before. I'm not sure if that would work without some significant stuff, as we saw in the fetch with proxy from Cooper here. It's not that easy to set up yourself. You have to write a custom fetch with proxy for that to work. And here's where the next spicy take is like, if they decide to override fetch so that you can pass it a proxied request, is that the same problem or is that better? My gut feel is that it's significantly better. And finally, you start to inspire and incite progress instead of pretending that it's happened already. The others just haven't caught up yet. You have me sold on this. I almost fully agree with what we're seeing here. Since the ball's already rolling, let's refactor the APIs from React and Next as well. This is going to be mostly boring because we'll apply the same patterns to all of them, ridding them of the same problems and reaping the same benefits. Again, the problem here isn't within your React code. Like, I like this a lot for within your React code and the calls that you own. They've actually implemented this already with react.cache. We have this. It shouldn't have been react.cache. It should have been react.dedupe. And again, the issue here is the reuse of the term cache when one of these things is very different from another thing. Yeah, and with cache, again, my assumption here is that for with cache to work the way it's being shown here, you'd have to change how fetch works to receive the with cache. And again, if we go to the code example, if that fetch call exists within library code, like get user info isn't your code, this comes from a library, you have no way to cache this part of this function. If you just want to cache this line, I can't reach into the library and do that. The fetch override isn't a perfect solution at all. I'm not going to sit here and pretend it's the magic thing that fixes all of this, but it made a lot of these edges a decent percentage more likely to be less annoying. It speaks volumes that both React and Next are already in a process of migrating away from patching fetch by introducing their cache and unstable cache APIs respectively. I hate the naming collision here because unstable cache is part of Next and it's a very specific, useful, cool thing for caching between requests. And then cache, which is React's way of deduping server calls. These are very different things, and them having the same name is a mistake. Things React should rename. Use server, use action. It used to be this, LOL. Use client, use interactive, react.cache, react.dedupe. Do I sneak in use effect? Do not use effect or you will be fired. We'll go with it. I've struggled conveying the idea of a concept in rules as something bigger than implementation details. Like with React, conceptually, it has pure functions, not just times that it happens to re-render. That's why concurrent mode, streaming, React compiler, etc. can be built later on the same API. Similarly, in Next, dynamic versus static isn't just for setting the defaults on a page. It's also to allow creating of partial pre-rendering. Expressing a dependency locally on the params isn't just to re-render layouts. It also expresses subpage requests, lazy fetches, and cacheability that comes later. I see similar misunderstandings of React.cache as a per request / page dedupe, but that's not what it is. It is a cache that depends on other inputs and that those can vary. It's a cache because it can be expanded beyond a single page and it can create stale values as a client cache. Patching fetch was never about deduping fetches, and patching date.now isn't about a specific thing. It just comes from the same principle of tracking inputs, like how Haskell tracks IO differently from other code. The same thing can be used for a bunch of stuff. Thanks for showing me a tweet where I get owned, Zeko. Appreciate that. Alternative take from someone much smarter than me. My rebuttal to Sebastian would be he's right in the sense that he's building React, and these things make a ton of sense for that, because the long-term goals are to do way more with this. My reason for disagreeing isn't anything to do with what he's saying here. It's simply that the average developer isn't smart enough to understand these things. And the naming is less about what it can do over time. It's more about educating users about these new things. And there's enough of these things going on that we need to make the ability for us to understand way simpler. We need to improve the education materials. We need to improve the developer tooling around the server and the client side and the relationship. We need to use names that might feel stupid in order to be very, very clear about what benefits and negatives and what behaviors we should expect with these things and how we should use them right now. And as bad as that might feel, it allows us to be more successful long term. So I think it's really important for us to lean into those things. Let's finish this article because there's a lot of good stuff here. Let's see the counter arguments too. Below, I'll address the most common counter arguments against my concerns, just in case the article failed to convince any of you that meddling with globals is a terrible idea. Who cares? Apparently, the thousands of people who watch this video, let me know in the comments if you care, because I'm curious who does and doesn't. But it's a better developer experience. If all the extensive explanations of this article failed to convince you that patching globals is never a good developer experience, I fear nothing will. Fair. I don't think that this is a great DX. I'll agree with that. My argument was never about DX specifically. Bun's a custom runtime. There is no patching. Bun is built on the promise of node compatibility. Node implements fetch according to the WG fetch standard, and so does Bun. They don't both follow the standard, but as somebody linked earlier, Theo commented here, so yeah, this is a bug. I personally think it's pretty cool that this bickering between Bun and Dino resulted in Node catching bugs, cutting issues for it, and hopefully long-term fixing these things. Really cool stuff. Like the standards are being followed better as a result of us trying to implement them. It's just funny that this silly poll by Bun is resulting in Node following standards better. Good stuff. Oh yeah, Bun is patching fetch, deviating from the standard, and introducing all the issues I talked about prior. Yes, I think they're doing both. I think on some hands, they're overriding defaults. On the other hand, they're pushing the standard forward and doing their best to figure, do we follow Node or do we follow standards or do we push Node towards the standards? But Node does weird stuff too. Of course it does. It's a project with 15 years of history behind it. I swim in that weird stuff on a daily basis at work. We should learn from its oddities and lead by example, not using them as an excuse to implement harmful APIs. Did I get pre-read again the other way? Oh, another one that I always drop. Fetch doesn't exist on the server. Global Fetch API has existed in Node since 2022. Yeah. It's starting to really work, but we're getting there. You added this one for me. Lol. I am honored that this got added specifically for me. Apparently, we have an example here of just patching or passing fetch with the proxy and it works. Header set forwarded from URL proxy, original URL. Yeah, assuming that the proxy server handles this properly, this should work fine, yeah. Cool to see people making proxy work without having to change fetch. Yeah, fine. It's taken so long for fetch to get to the server that still iffy on this, and we're still figuring out what fetch on the server even means. I think working around it and doing what you need to is fair. Like, people in React Native are still heavily using Axios. Like, we're catching up still. Oh, apparently we can't use the UNDC1 in Bun because it doesn't export the proxy agent for the Bun version. Thank you again, Cooper, for stopping in. But the fact that none of this is that easy is hilarious. God, this is chaos. But these frameworks know better. They likely do, but in some cases, it takes them time and feedback from the community to arrive at the better. As I've mentioned before, React and Next are moving away from patching fetch in favor of more explicit APIs. When I asked Lee to provide more context behind the switch, he shared with me the following. In theory, community packages could publish their own code that used fetch and set these caching policies on their own. And we started to do that a bit, but it was very opaque and hard to tell why something was cached. So we decided that we wanted to be more explicit. Yes, but also it's hard to tell why. This is still a developer tools problem that I think really needs to be a focus. Perhaps we'll even see Bun reconsider their direction of patching globals, which would immediately make it a more mature runtime, at least in my eyes. The bottom line is as follows. There isn't enough amount of experience, skill, or credibility that would render you immune to making a mistake. Yep, I've seen some of the smartest people in the industry make really dumb mistakes, like changing use action to use server. The only thing that matters is having the strength to admit one and the wisdom to resolve it once you do. I hope this article was able to shed some light on the dangers of apparently controversial practices of patching globals. It's a foot gun, and we've already fired it. It seems that we need a due reminder that the feet we have are just two. And again, a thanks to Lee Robb and Jordan Harband for proofreading the piece. Really love that you got other people to give you eyes on this. Fantastic blog post. It did a great job of reframing the concerns about this. And it's changed my stance too. I now have a much clearer relationship between the behaviors being changed and the API being changed. That's enough yapping from me though. This is a long video. Let me know what you think. And until next time, peace nerds.